powered by Gemini 2 Flash Lite and deployed through Vertex AI. This project showcases how generative AI can be used to make product recommendations smarter, more contextual, and user specific, just like a real assistant that understands what you like, what you bought, and what you're looking for. Shoppers often face decision overload on e-commerce platforms, and there is a generic product license lack. Uh, generic product license lack the user context. So there is a need to also key in the user context. And we'll walk you through the logic step by step, from loading product data to retrieving matching items, applying user preferences, generating responses using Gemini, and finally evaluating the results. And I'm completely using Google products, Google platform, and GCP uh, for this project. I'm using Google's Gemini 2 Flash model as an LLM model. The deployment platform is Vertex AI and Collab on Vertex AI. And the user interface that I'm using is on Radio, but this whole project is hosted on Google Cloud. So what the assistant does here is, at its core, the assistant takes a natural language query from a user, understands the user's interest based on past purchases, retrieves relevant products from a large product database, uses Gemini Flash to generate a personalized conversational recommendation, and finally lets users rate the recommendation and helps evaluate its quality. Also, I'm using Kaggle Amazon 2023 dataset with over 1,000 products. We are cleaning and renaming the columns and normalizing the categories, retaining only the top level product categories, such as electronics, etc., to make filtering and matching easier. Why we are using Vertex AI is because it connects to Gemini models via API, allows scalable, secure inference, and it removes the need to host models locally. It's a lightweight. Gemini Flash is lightweight. It is very fast and optimized for tasks like product summarization and chat style responses. And what we'll do here is we'll simulate a user's past purchases, infer top categories, and use that as context. For example, if a user bought headphones and smartwatches in the past, we treat electronics as a preferred category. And then there is a semantic product search with face. Each product test is converted into an embedding using mini LLM. We index them in face to enable fast similarity search. A user's query is embedded and compared against the index to retrieve the most relevant products. At the end, there's a personalized recommendation with Gemini Flash. We passed retrieve products, user preferences, and the original query to Gemini Flash. Gemini generates the human-like recommendation, describing the best products with reasoning and comparisons. And this is where the assistant feels truly intelligent and contextual. Step the next step is the gradual user interactions, where it provides interactive UI, where the user enters the query, operates are shown in a table, Gemini's response is shown, and user provides a feedback. And finally, we are evaluating the recommendation using precision at K, NDCG at K, and hit at K. But precision at K means how many recommended products are relevant. NDCG at K means do relevant products appear early in the list, and hit at K means did at least one relevant product get suggested. And we match Gemini's output back to actual products using fuzzy logic. The project shows how to combine data, user context, search, LLMs, and evaluation into one intelligent system. We believe this is a strong use case of RAG plus personalization and a great example of how Vertex AI and Gemini Flash can power modern e-commerce. So, in order to save some time, I have already run few of the steps, which are basically setting the libraries, Python libraries, and the LangChain, Google Generative, Pandas, Gradio, and all, and initializing Vertex, uh, installing transformers, and so and so. I have run it till here. I'm using the L4C uh, GPU here. So till this step, I have already done it. So the next step is I will be importing some of the libraries, and then we will initialize Vertex AI, and we will see the live performance of this model. So Vertex AI initialization, I'm using, I have a specified, I've defined a project ID in the Vertex. That initial setup I have not shown here. I've already done it. That's a deployment strategy. And then there are the libraries, LangChain, Google Generative AI, Pandas, Graduate, etc. And I'm using the Amazon sales data set 2023. I've taken it from the open source in Kaggle. So this is the way the data set looks like. So there will be some sort of cleaning done in the subsequent steps, like renaming some of the columns to simple names and so on. So now the next step is about the dimension. It has 1465 rows, 16 columns. There's the info part. These are the columns in this data set. And now here I'm renaming the columns and changing the names of product name to product, about product to description, and so and so. For the self-explanatory. And then I'm keeping, I'm then extracting the unique categories here. So these are the unique categories. Each category value has uh, that and a symbol in between. That means there is a string, and then there is a string, then there is a string, and what we'll do in the subsequent step, we'll only retain the first part of that category value in each field of category. So which we are calling as category normalization. So we are splitting it and retaining only the first part in this step. Again, it is pretty self-explanatory. So now we have the unique categories, as these are the unique categories from the extracted data set. So what we'll restrict the user or a buyer or a shopper to only choose products from these categories. Otherwise, the model will hallucinate. So that's the restriction imposed. And if the user selects any category outside this, then there will be an appropriate error message thrown. I'll show you in the subsequent code. So these are allowed categories. Now comes the initialize sentence transformer and category embedding part. So here uh, we are using the sentence transformer model, all mini LLM uh, LML6 V2 model to embed allowed categories and compute cosine similarity with the query. So basically, there could be some vague category or misspelled input by the user, and that will be brought closer to using semantics, closer to the expected search string using semantic similarity. So this is how the logic is. In the next step, we are creating a sample user preference data frame with previous purchases. So we are actually recording this. I'll show you in the final presentation that we are actually recording the user preferences in a CSV format, in a CSV file. But as of now, let us understand that I have a single user who is at one point of time searching for smartwatches, secondly users, third keyboards, and then it is mapping to the respective categories. So this is our model will use the user preference or the user history also into account. So that is also this is also a context based search. Now we have the face search with an embedding of static data set. So here we are encoding the product text, that is title plus description, and we are building a phrase index and then retrieving top case similar products based on the user input query. So basically, this helps in efficient vector-based retrieval, as you know, in the face. Now comes the Gemini's response with personalization and category check. So what it does, it creates a prompt for Gemini using user preferences and retrieve products. The prompt is designed to guide the LLM in generating helpful tailored shopping advice. So basically, this can also be categorized in the LLM tuning part because here we are designing the prompt. Next comes the section where we are doing a Gradio web app with feedback collection for evaluation. What we are doing here is this function handles the full query response loop. It parses input, fetches products, invokes Gemini for reasoning, logs evaluation metrics like precision at K and NDCG, and returns the final reply and scores. This function shopping assistant interface, if you see this function shopping assistant interface, actually serves as the backend logic for the Gradio powered shopping assistant. It takes a user query and optionally feedback, then performs several critical steps. First is it uses semantic category detection via closest category function. So first it is doing a semantic category detection to map the query to a known product category. And then it filters the dataset accordingly and retrieves similar products using fast-based semantic vector search, which compares dense embeddings of the query and product descriptions. This is the first step it is doing. Then secondly, it generates a response using Gemini Flash Model, summarizing and recommending items based on both the query and the filtered products. The model output is passed using regex and fuzzy matching. Now, when we talk of fuzzy matching, we say it is the function is get close matches to map generated suggestions back to actual product titles from the dataset. So to go back to the actual product dataset, it is doing it is parsing the output using regex and fuzzy matching. The final match titles are stored for evaluation and feedback logging. If user feedback is provided, it is appended to a CSV log with timestamp and query metadata. Basically, we are using for the presentation sake, we are using user defined defined user history dataset, but actually the Gradio can create that user preference. So if you have to scale this code uh, in a production environment, then we can use the Gradio input as the user history dataset. So the Gradio interface then presents the matched product title, Gemini's recommendation text, and optionally the internal list of matched product titles. So basically, this is a single user test that I am showing you, and so we are just keying the user preference in a history file for the sake of presentation. But in actual production scenario, there will be multi users, and each user's preference will be accordingly validated. So this is the next step. Now, if you see this, it is opening up a Gradio interface. Now, this Gradio interface can also be opened in the new tab, whichever way you want to. Right? So let us say the user query is looking for kitchen juicers below 10,000 rupees. We'll see what our model is recommending. So the previous run had some issue. So this is how if the user sends a query looking for a kitchen utensil with a 10,000 rupees. So these are the such products recommended by uh, that comes up regarding to Gemini, and this is what Gemini says that you can see the okay, based on your interest in electronics and all. So it gives a very descriptive definition generation of text, and it will give the reasoning why this is recommended, why it is not recommended, what is the user rating, and so on. So based on this, if the user finds, like let us say this particular one, which is these are all less than 10,000 rupees, right? Most of these, this is not this one which is higher than 10,000, probably 20,000 something. So this is a wrong recommendation, but these are the right recommendations, and the user presses this and says, okay, this is a good one and very helpful, and gives a feedback, submits the feedback. Then that goes and that is stored in a user context. This is basically the recommendation feedback log file, which we were talking about. And the next time when the user keys in, it is used from that feedback file to set the context for the user. So basically, the system will not prompt anything undesirable product to a user. So it understands the user, his choices, and then accordingly it suggests. The last step, as I said, this is the last step. This is basically, if you see the value here, uh, the precision at K. At K means the top K. K is 5 year. The precision at K is zero point 0.6, NDCG is 0.72, and hit is 1. Basically, these are the evaluation parameters of this model. This is very important. Uh, this particular code powers a shopping assistant by combining multiple types of similarity matching uh, to enhance product recommendations. It uses semantic similarity uh, via sentence transformer to embed product titles and descriptions, enabling face to perform efficient vector-based nearest neighbor search. This helps identify conceptually similar products even if exact words don't match. The assistant also applies fuzzy string matching using difflip.getClose matches. So you can see the difflip got so there's matches. So in this, so basically uh, that that uses fuzzy logic to align the Gemini model's free text outputs with real product titles from the dataset. A key part of the personalized logic involves the use of user preferred categories, which are inferred from the user's past purchases, as I said. So these categories form the ground truth of for evaluating how relevant the recommended products are, and so on. So the evaluation step compares the top K Gemini suggested products against those preferred categories using metrics like precision at K, NDCG at K, hit at K, providing quantitative feedback on recommendation quality. So if you see here, the same query which I keyed in here, the same query which I keyed in here, I am running here. In the subsequent evaluation section, we check the model performance parameters, how efficient the model is. Look here, sample query. This is what I'm doing here. So this is how this whole project was built using Google GCP, uh, Google's cloud Vertex AI platform, using Gemini to Flash LLM, and powered by RAG. And we have used semantic retrieval with FAS and product reasoning via Gemini Flash. And we have also used Gradio for UI interface. And the data set, as I said, used Kaggle 2023 data set for Imagine 2023. and I used a lot of personalization logic. I took help from Copilot, Google's Copilot, in designing some of the complex queries. And the idea was to build the complete product on GCP on the cloud and deploy it. And I have also uploaded this code uh, in GitHub. That's all I have here. And if you think that this can further be improved in future, so these are the points. You can scale it, or you can add more interfaces, and you can also host it in the Streamlit web application and all. So I leave it for future improvements. But for now, this is what it is. And thank you for watching.